Okay, so students are going to be asked to find lines of symmetry, and symmetry is one of those things where I think for those of us who get it, it feels fairly intuitive, but when you start to do it with kids, you realize that actually, like, there's quite a bit of, like, anchoring that's necessary to not just, like, be guessing, and it's not just about, like, seeing it clearly, just because that takes practice. And so this lesson is fairly, I would say, complex, and you want to hit all the complexities and make sure the kids are understanding all the complexities, and you know that, of course, because they're going to be talking to you and explaining. We're going to learn about symmetry. Symmetry is when a shape can be divided into two matching halves that are mirror images of one another. Most faces have one line of symmetry, so if you look at Beyonce's face, right, she has one line of symmetry. I think the thing to talk about here is that, like, symmetry is nature's way of showing that something has kind of grown correctly, right? If we saw a flower that had grown like this, we'd think something was wrong with the flower, right? Symmetry is, like, an important thing in our world. One way to check for symmetry, and it's when you have this mirror image, right? So one way to check for the mirror image is to fold the shape. And students are going to actually get a piece of paper with these 4 shapes. They should cut them out and fold them. And the reason is because these shapes get really mixed up very often. And these are the shapes, especially the square and the rectangle, that are going to become your, like, anchors for evaluating other shapes. So, for example, once you know the symmetry lines in a rectangle, this shape becomes easier because you kind of can imagine a rectangle inside of it, right? So that's, like, what I was saying. Like, symmetry is a little more complicated than we see. Plus, kids have to actually fold it for themselves to really understand, that it's symmetry versus half. And you're going to see what I mean in a minute. So, first of all, you'll do the square. The square has 4 lines of symmetry. Here, 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 and here. And a lot of kids are going to think that because the square has 4 lines of symmetry, the rectangle has 4 lines of symmetry, but the rectangle actually only has 2, here and here. And if you try, by the way, to fold it this way, you should try and show them these corners don't match up. And if you try to match up these corners, then these end up not getting folded perfectly. And so it only has 2 lines of symmetry. And so that's important for us to distinguish. The other one that we want to think about is this shape. Because this has 2 lines, people might think that this has 2 lines. This one, it doesn't. It has no lines. Just because you can cut it in half, doesn't mean it's a line of symmetry. They're not going to meet up across from one another. This has 1 line. So you see, they really need a hands-on approach. They should memorize these 3 at least, the square, the rectangle, and the parallelogram. And that will set them up for future success, because you're going to look here and say, what kind of shape might you see inside this shape, right? Oh, I can see a rectangle. Then great, this probably has 2 lines. Let's check. Yep, it does, right? When you do this shape, this is a fun one to let them talk about. It has a lot, they might say, as long as it goes through the, center. Do a nice job. We say that it has infinite lines of symmetry, and you might say infinity and beyond from the Toy Story movie. That helps them know that infinite means it goes on and on forever. But of course, this shape doesn't have infinite lines. This only has 1. This has 1. So you do that, and you let them tell you about the rest. You do your little cutting activity. You let them talk about these shapes and tell you. And now you're going to do the cutting activity again, only this time with these 2 shapes. And now you're trying to develop some other understanding of symmetry. They're going to fold this. They're going to fold this. They should get, for this shape, 3 lines of symmetry. It's a 3-sided figure with 3 equal sides. For this one, they should get 5 lines of symmetry. Each of these angles can be cut. And partly you could imagine turning this shape to look like it did with that first top cut. So they cut, they fold, and now you use this table to discuss what you found. You just did the triangle with 3 equal lines of symmetry, or 3 equal sides. It had 3 lines of symmetry. The square we did earlier had 4 equal sides. It had 4 lines of symmetry. You're letting them help you do this, of course. The 5-sided figure you just did, called a pentagon, had 5 lines of symmetry. What pattern do you notice? Great. Let them tell you, right, when it has equal sides. however many sides it has is how many lines of symmetry it has. Great, so we can fill in the rest of this chart and be predicting, right, what other shapes would be. So what do you think this one's going to be? What do you think this one's going to be? So you see, symmetry can be a lot more complicated than we expected, right? There's both anchor images that we want to have in our mind. There's also this pattern that we can use for what we call regular polygons, polygons with equal sides. And all of that kids need to bring to the table when they're looking at some random shape, so that they're not really just guessing, but they've got some foundation to base their eyeballing on.